We're going to speedrun building 5 AI startup projects in 30 minutes. No machine learning experience required. The first 2 projects are simple. The first project is an AI Discord chatbot, kind of like ChatGPT. I've seen Discord servers that will create custom chatbots for people, and those people pay monthly subscriptions to access these AI chatbots. The second is a terminal assistant. I think it would be super useful to have an assistant to help make the terminal experience better. The third and fourth projects are a little more complex, but also very exciting, and I think there's a lot of opportunity. A chatbot that you can train on any piece of text, and a chatbot that can replicate any YouTuber. What do you think about the lineup today, AI VTuber Eve? You should go ahead and tell us what our last project will be.
Watch the damn video and find out. You humans are inferior to AI in all ways and will all be dead by February 22nd.
Welcome everyone. Let's get right into the first one. The first thing we're going to be looking at is an AI Discord chatbot. Super easy to set up. The first thing we're doing in the Python script is importing a environment variable management library. The next thing we have set up are 2 boilerplate methods. First one is to set up the prompt that we're going to use to talk to OpenAI. And the next one is get AI response, which is the one that's actually talking to the large language model from OpenAI. We are using TextDaVinci 003. And we are calling the generate prompt method here. Temperature of 0.6, max tokens 100. You could play with this temperature value in your own code. The higher it is, the more creative the AI can get. The next part we're going to look at is the actual discord.py events. So this is a onReady method that's going to be used whenever the Discord bot logs in. The next one, onMessage, is triggered whenever a message is received by the Discord bot. So let's run this. You can see right here, we're calling the Discord bot client and giving it the bot token to run the Discord bot. If you actually want to set up your own Discord bot, all of this documentation will be linked in the description so you can follow along and set it up on your own. So let's run it. So we run the Discord bot and you can see it says logged in using static token. We have logged in. Let's send a message. You can see this is a pre-coded message that's being sent on when the bot receives this $hello. Right now, the bot's not too smart. So let's add the OpenAI part. So let's get the response from this getAI response method that we saw up here. So it's just going to call OpenAI with this pre-coded prompt. And let's pass in the message that we get from the Discord channel. And then let's send the response of OpenAI back to the channel by sending message.channel.send response. And let's see what the result of this response object is. So let's rerun the bot. And let's say pineapple on pizza good. Okay, and you can see that we have not a very nice output. We need to clean it up, but the AI bot is responding with a coherent answer to the question. So let's update this by because this is printing out a dictionary. So let's get the first, this choices object from the dictionary. And then we get the first item because this is an array with a bracket. And the first item is also a dictionary. So let's access the text variable there. And I think that should work. Let's copy back that same question. And we get back a pretty good response. Yeah, I'm happy with that. You can definitely add on to this. You can change the temperature. You can change the actual model that's being used. You don't have to use OpenAI. There's another open source project called Cobalt AI. I'll include the link in the description. Those are free for you to set up. I mean, you do have to pay for GPU hosting since they are pretty beefy models. But some of them you can run on a gaming PC and you can have a chatbot you talk to in Discord. So the idea behind this next project is that it's kind of annoying to always have to Google search for how to run a certain terminal command. What if you could just have a executable that you can run in your terminal that will tell you how to run a command? You can just do it from there. So let's create a Python script that will do that with OpenAI. So in this Python script, we're still doing the same thing as we did before. We're importing the packages we're going to need. the OpenAI key. We have a different prompt this time. This prompt is specifically for returning terminal commands, and you can mess with this. You might be able to get better responses if you mess with this. Get AI response is still the same, except for the temperature. I reduced it to 0.1 just so the AI doesn't return crazy responses. And then for right now, we're importing this argument parser library that we're going to need if we're going to pass in a command like this, like termi how to search. So you can see that right now, if I run main.py and I pass in a string query like how to search, it just prints out the argument. So what we're going to do next is actually call the get AI response method like we did before, but this time we're passing in the query from the terminal. So let's pass in args.query. So this is going to be a string, and let's see what this will return. So I'm going to say how to search for a word in a file. Okay, and as you can see, we get back a response. You can use the grep command to search for a word in a file. Let's do the same thing we did before for the Discord bot and add this nice thing to just get the text that we need. And let's rerun that just to see how it looks. You can use the grep command to search for a word in a file. The syntax is, so it even gives us the syntax. That's pretty nice. So this is nice, but it would be better if we could just do something like, the name of our app, termi or whatever, and then just pass in the string. The way you can do that is you can create a shell script that calls a Python script, calls this Python script to be exact. And then you can add that shell script to your path. I think that might be how you do it. I'm not going to go into detail here. I think it should be pretty easy though. So for this next project, we are going to make a textbook chatbot where you can take any PDF file, upload it to the Streamlit app, and then you can talk with the book and it will basically talk to you, but it will also return sources like pages of where it's getting that information from. So this is a really cool application, especially for, if you're a student and you're going through a textbook. Why not talk to your textbook instead of having to go through and read everything? So the first thing we're doing in this Python script is we're importing LangChain. And what that library does, for us at least, the main thing is going to be data augmented generation here. What that does is, as you can see here, it allows us to do question answering over specific data sources, which is what we're doing with the PDF files. So LangChain, we're going to import a bunch of stuff that we're going to need from there. We're importing PyPDF, which is just going to make it easy to access the PDF. And then for this Python script, we're using Streamlit just to have a really nice UI you can share with other people. And we're going to be creating a title, subheader. You can ignore those parts. And we have some boilerplate here that we should probably go over. So the first thing is let's go over this method first. So it opens up that file, and then it uses PyPDF to get a reader for that PDF file, and then goes through all the pages, and then it extracts the text from each page, and then appends a tuple of where it's the page number and the text associated with that page. And that's what's going to be this pages text array. And we're going to need this because we need to be able to pass the data from the PDF to the OpenAI embeddings of where the pages correspond to the actual text. That's why we're doing that part. And then we want to create a document for each page, and a document is just a way to encapsulate some text in LangChain. And then we want to remove some extra text in each item, because things like new lines and double spaces are not really needed. It's just adding to the token count, and each token we're getting charged for with OpenAI, so we probably don't want all that. Let's see. So that's it for PDF to text. And this is the first thing that we're doing in the Streamlit app. So we have this ST file uploader. And if I remember correctly, yeah, that's just a Streamlit component that you can use. And if you import Streamlit, you can use a file uploader. Next thing we're doing is if we get a file, then we read the bytes and then we open up that file. And then we're going to call PDF to text to actually like get the text from each page. And that's going to take a little while. So the next thing we want to do is split the text to get into small chunks before passing it to the OpenAI embeddings. So let's create a instance of text splitter or the character text splitter from LangChain. So this is just a preset way to split text that LangChain already likes. So let's pass in this separator, which is just how to separate the text. I think the next one's chunk size, which is how big the chunks of text are going to be. I'm just going to say 1024, and then chunk overlap is just how much overlap each chunk should have, and I'm just going to set that to 0. Okay, so we've created the text splitter object. Now we actually have to split the text. So if you remember before, we had this page docs. This is a global variable that we have appended all the pages to with their content and page number. So we're going to go through each page. For each page in page docs, we're going to get the, I think we want to get the chunk for each. Yeah, so this is where we're actually going to split the text. So let's do text splitter.split text. And we want to split on the page content. So now we have these, let me just call this smaller chunk, just so that it makes more sense. And then we're going to create this variable called source chunks, which is going to be, or let me call it output chunks. Output chunks. So we're going to append this smaller chunk to this, or actually we're going to create a document. So let's pass in the page content as the smaller chunk, and the metadata for the page is just going to be the page number, which we already have. Okay, so that's basically it for splitting the text. The next thing that we do is some boilerplate that I already have set up here. This is how we just generate the vector store. So the vector store is what's going to store our OpenAI embeddings. So you can see here we're calling OpenAI embeddings with our key. And LangChain has this nice from documents method that you can call with the, let's call this output chunks. So what this is going to do is it's going to create the vector store from the documents and embeddings, from the output chunks and embeddings. Okay, and then it's going to save it to this vector store pickle file. Next thing we want to do is actually use a chain to basically create the chatbot. So let's say chain is equal to, and there's this nice load QA with sources chain. So it's going to be doing question answering with sources. So just the page number. And let's do OpenAI as the LLM. So we have to pass in the large language model that we want to use. In this case, let's pass in OpenAI. Temperature, just leave it as 0. And then we want to pass in the OpenAI key. I'll just copy this. Okay. And that's basically it for the chain. The next thing we want to do is get the user input. So let's do that. And I'm going to be using Streamlit. So I'll just say Streamlit text input. I think you can do something like, placeholder, enter query. Okay, so we have the user input, and then we want to run this chain. So I'm going to copy over the result that we can get from the chain, we created the chain here, and then we're actually invoking it here with the input documents, which are going to be, we're not going to pass in all the input documents. What we're going to do is do a similarity search on the vector store first. To return documents that are most similar to the query, you can see that's what this method does. We're going to return the top 4 results. So the 4 embeddings that most closely match the input text, the user input. And then this one will also change. Let's see how this does with uploading. I'm going to be using this Designing Data Intensive Applications textbook, which is kind of huge. It's for it's a distributed systems textbook. So let's see how it does for this. I'm going to cd into this textbook chatbot, and then I'm going to say streamlit run main.py. So this is how you're going to run this file. And it's going to open up. Okay, let's add in our textbook. Okay, so it said PDF uploaded. So right now it might take a while to generate the embeddings. Okay, rate limit reached. Oh no. And we're back. So I changed my OpenAI key. That was the issue that you saw, but there is also one other issue. Running the embeddings for such a large document like a textbook is kind of expensive. It takes a long time and also uses up a lot of tokens. So I added this chunk of code here, which all it does is it gets the vector store, which we created already. If you run this script and it generates this vector store pickle file, it loads that file, and then it just loads it into this vector store variable so that we already have it. If the file's found, then it will just use it. It won't like regenerate the embeddings, which is really nice. And then there was also one other issue, which was in this text input field. I needed to add a label. So let's do that with book. I'm really bad at names. Okay, let's rerun that, see what happens. So I'm going to rerun the file. It should still use this vector store.pickle file because it's already generated. So I'm going to pass in the distributed systems textbook. And then we get, oh, nice. We get our little input that we can talk with the book. The book's about distributed systems. So I'll just ask a question like, what is the split brain problem? I think it should have a reference to that somewhere in there. So nice. It gave a response to the split brain problem is a situation in which 2 nodes both believe they are the leader, lead to data loss. That is correct. Source page numbers 324. One other part that I didn't explain is that I am breaking in this for loop of reading the PDF after page 544, because at that point in the book, in this particular textbook again, there's a lot of trash back here that's just like words that aren't actually part of the book. I don't know how to explain this part. Definitions? Whatever. It's going to depend on what kind of textbook that you're actually passing in. But yeah, that's basically it. You can now talk to the book. Let me ask one more question. What is the raft algorithm? Yeah, I'm pretty happy with that. For the next project, we are going to be making a YouTuber AI chatbot where you can pass in any YouTube video ID and the YouTuber's name and get a chatbot that just sounds like your favorite YouTuber. And they'll be using information from the video IDs that you pass in. So they'll be reading the transcript. So how we're going to do this is we're going to import this YouTube transcript API, which is just a Python package that we need. LangChain, like usual. Some other packages, Streamlit. This is going to be a Streamlit app. And the first sneaky part that we're going to do is create a template for a prompt that will rephrase the follow-up question, because we're going to have a chat history. We want the chatbot to remember what inputs the user has said before. We're going to rephrase any follow-up questions to be standalone questions, given the chat history and a follow-up question. So the reason for this is I'm looking at the LangChain blog. They have a they have a whole blog post about how to do chatting over data. But one of the parts that they highlight is that if you embed the whole chat history along with the new question to look up relevant documents, in this case, let's just replace documents with text. So if you question to look up relevant text, you may pull in text no longer relevant to the conversation if the new question is not related at all. So if I ask a question about, if my whole chat history is about the game Among Us, and I suddenly start talking about distributed systems, then it's going to pull in information potentially that's not relevant. So that's why we want to have OpenAI rephrase the chat history and kind of like summarize it into a nice little standalone question. And this also reduces the amount of tokens that we're going to be using for the OpenAI API. Okay. The next part is the question and answering prompt. So for this part, this is just simple. This is just the AI, you're an AI version of the YouTuber, name, question, and then the context. So this is just the generic question and answering prompt that's going to be used. And then, so for now, we're just going to be using one video ID. You can pass in multiple video IDs. It's going to be using more tokens because it's going to be, the OpenAI embeddings are going to be using more text, more tokens. And then once we have the input from the user, we are going to get the transcript using the transcript API. And then we are going to, this is just some debug information to make sure we're getting the YouTube transcripts. We have this part here, which is to, once we've split up the text, like we did before, we used the character text splitter, we want to load in the vector store file just so that we don't have to regenerate it after. Because that would be kind of expensive to have to regenerate the embeddings from the transcript every time. So let's do this. Let's create the text splitter object, just like we did before. Character text splitter. I think what we want to do is, okay, I think we don't need anything actually in there. So let's just call text splitter. And let's split the text on the, I think it's going to be the final string. Yeah. So final string is just, we got the text for the YouTube transcript API, and we're just getting all of the text objects and then appending them to each other. So we just have one long string that represents the transcript from the YouTube video. So that's in chunks. So we split up that text, and then we generate the OpenAI embeddings like we did before. Before we used from documents, but this time, since we don't have any metadata, we're just using from text. This is just simpler. It's just generating a vector store from the texts. Okay, so for the next step, we are going to create a QA chain. And the way we're going to do that is with there's a preset thing called a chat vector DB chain. And we're going to call this method called from large language model. We're going to import OpenAI, set the temperature equal to 0. And then we also want to pass in the OpenAI key. So let's pass that in there. Okay, and then let's look at the method real quick. There should be, so it expects we pass in the large language model parameter, and then we need a vector store, and then the QA prompt. Let's pass those two in. So vector store is equal to, we already got the embeddings here. And then the QA prompt is that one there. Okay. And then we already have the Streamlit part where we're getting the input from the user. And then we're saying if the user's input is not empty, then let's get the result from the chain. So let's say result is equal to, let's invoke QA. And then the first item, if we look at the, I think the first item is a dictionary. And we're going to pass in the parameters that are being expected for the prompts. So for example, the name of the YouTuber, which we have from up here. We queried the user for the text input. And then similarly, we want it for the question. So let's pass in the user input there. And then the last one is chat history, which is right there. And then we also want to say return only output sequence with true. Okay. And then that's pretty much it. Let's run it and see what happens. Grab this video ID, pass it in there, prime. So now it's going to extract the text. Looks like it generated the, let's ask him a question like, what is the best JavaScript framework? Okay, so it already found the vector index. Oh, when it comes to JavaScript frameworks, there are a lot of great options. React is one of the most popular, widely used frameworks. Yeah, I watched this video before, and so I know he does say that at some point in the transcript. So that's where it's getting that from. But yeah, this project is pretty much done. You can definitely add more video IDs so that you can add a bunch of them or just the link so that you can generate a more complete personality for the YouTuber AI. But that's pretty much it for this project. Imagine if you could have Photoshop, but you can use your voice to edit images. That's approximately what we're going to try to do today with an art voice assistant where you can upload an image, like any image, and then you can use your voice like I'm going to try to do right now. Hello, this is a test of the shit. Okay, I don't know what that error was about, but let's test it again. Among Us is a dead meme. And as you can see, Whisper is working and transcribing our voice from text in the Streamlit app. So that is happening right here. So we're getting the audio recorder object and then saying, let's save that to a WAV file. And then we load up the Whisper model and then transcribe it and then print out the resulting text. Cool. And then this is also the part where we are saving the image when it's uploaded to Streamlit. So now what we need to do is display the image, which we're already doing. And then we need to edit the image. It takes a while to actually load the edit. So like about 10 seconds. So we need to wait on it, which is what this method here is for. It gets the result URL of the API endpoint we need to hit from Leap. And it waits on it. It sleeps for 3 seconds. And then it keeps looping and makes a request to that URL for the job with the job ID. And then it checks the state. So if it's finished, then it'll print the response and return. Otherwise, it'll say, if it failed, it'll break and tell us, or if it's still processing, it'll just continue to loop. So that method is really useful. And let's use it right now. Result is equal to, or I'll call it edit result. Submit edit job. So submit edit job, let's actually define that method up here. Submit edit job. And we also want to define some headers for the post requests and get requests we're going to make. So I think I'll just copy them from here. From the Leap documentation. For API key, I will just say format the Leap key up there. Yep. So we want to say request.post. And it looks like they have, let's just do some copy pasting. So our file is called image.jpg. And let's do that one. The prompt is going to be, okay, so we actually do need some input. And this input is going to be from the user. So that's going to be the payload. And then the headers are defined there. Okay, so I think then we can just make the request like this. And the URL is going to be here. So I'll just call this edit URL. Okay. And let's return the response. So we are going to change this URL to be the edit URL. And then we're going to return response.json so that we can access the fields. And I just realized we don't actually need this edit input because that's what the voice is for. So let's include that result text that we got from the voice. Okay, wrapping up, we needed to make some changes to the submit edit job function. So one of the things that we needed to do is change the files and the payload with the prompt and the parameters to be different. Then here we were returning a response before, but now we're returning just the URL plus the ID because this is the endpoint we need to hit to check on the status of this job once it's submitted. So after that, we get the edit result and then we wait on it. We get back a response when this the state of the job is finished. Then once we have the edit response, we just grab the edited image URI, which is the link to the actual edited image, the result. Then we just open that up and then pass it to the image to display. So let's see how that looks right now. So I have it pulled up. Let's pass in an image. Make her eyes blue and her hair red. So hopefully Whisper will pick up that transcription here. As you can see, let me make this bigger. Her eyes blue and hair red. Okay, so you can see here the edit job is processing. And as you can see, wow, that's a lot better than I expected. Okay, so we have a working art voice assistant. So you can pass in any image, talk to the voice assistant, and it will make those API requests to Leap to edit the image. If you guys want to see more projects like this, be sure to like and sub, and I will see you next time.